get 3. But you're not allowed to just multiply the bottom of a fraction by something. You've got to multiply the top by the same thing. So that's how 1 over square root of 3 becomes square root of 3 over 3, and now we don't have a radical sign on the bottom.
Should you always check it like that after you do it?
Yeah. Math books are very picky about this. However, I'll tell you, some standardized tests will go ahead and leave the radical on the bottom in their multiple choice answers. I don't know if they think they're doing you a favor by sparing you a step, or if they're just trying to confuse you. But, yeah, I mean, mathematically, this is always the most correct way to write it. In terms of your standardized test experience, you should know that these two things are the same and be able to recognize either. Okay? My apologies for that. As I've told you guys before, there are many math rules I would change if I could. Math notational things. Any other questions on this one? Okay, guys, remember this is a great example of what I said. These problems require you to basically remember everything you've ever learned in math from at the 5th grade on up.
Okay, last week you were saying
7th grade? Well, yeah, depends on when you learn complex fractions, I guess, and square roots. I don't know, when did you guys learn that a square root is plus or minus?
8th grade.
8th grade, yeah. Just now.
Last
2 seconds ago. Depends on your individual math experience may vary. Okay, good news. Today we get to something less abstract. Okay, what we're going to start today actually has a purpose in the world. So you're going to learn something called the Law of Sines today, Law of Cosines tomorrow, and it'll be word problems after that on how people use them. I wish I had said this on Friday but forgot, but so for the rest of the week you need your calculators.
Is this the thing with the, that you were telling me about on Friday?
Yes, we're doing the other one. We're doing the Law of Sines first. You and I talked Law of Cosines when you asked that question. Okay, so the general thing we're talking about is solving non-right triangles. Okay? Solving non-right triangles. You guys remember on the last test you had solving right triangles?
Yeah.
Yes? Okay, good. You remember to those are easy. What did you what was the rule for that? If you had
have at least 2 pieces of information, then you can solve the whole thing.
Yes, boom, you got it. As long as at least one of those pieces of information is a side length.
Okay.
Okay, yes, very good. Now the reason why you only needed 2 pieces of information for that is because you always knew one of the angles was 90 degrees, because it was a right triangle. These are non-right triangles. You don't know what any of the angles are.
So how do you solve them?
I'm glad you asked. Okay. First I'm going to draw a non-right triangle.
That could be right.
This could be a right angle up here. Please pretend with me that it's not, because that's one of my prettier triangles and I'm not sure I can draw it that well again.
I feel like I've done this before.
You may have.
On like the last unit that we did. On one of the homework things.
There were a couple where you had to take a non-right triangle and split it into 2 right triangles.
Oh.
That's not what we're doing.
Darn.
Okay. I've tried to label this so that my smallest angle is the capital letter A, my smallest side is lowercase a. Medium angle is capital B, medium side is lowercase b, biggest angle is C, biggest side is lowercase c. I feel like I'm talking about Goldilocks and the 3 sides and the 3 angles. Okay. Depending what rule you use, Law of Sines or Law of Cosines, there's 2 of them. You're going to learn one of them today, but I want to go over, you use a different rule depending on which information you're given. And the way your book presents the information is kind of like how you were classifying knowledge you had about triangles in geometry. Do you guys remember things like the side theorem?
Yes.
Side angle theorem, that kind of stuff?
They're not angle side, never angle.
Never angle.
Except for in this.
We'll get to angle side, believe it or not. Or side angle, as the book likes to have it to avoid an unfortunate acronym. But for Law of Sines, I want to go over the cases first. Okay, if you know angle, side of one triangle. Now these rules you learned in geometry are always describing 2 triangles. Okay? But in this case we're only talking about 1 triangle. But if what you know is angle, side, and the order is important, this actually describes a case where maybe you know this angle, and this side over here, but you've got to know two angles in a row and then the side that is not in between them. Okay? We'd use a different rule if we knew this side length. If you know angle, angle, side, you use the law of sines. Okay, and I'll write that at the end. If you know, if the pieces of information you know are an angle, a side, and an angle, like let's say you know this angle, this side, and this angle, you'd also use the law of sines, which again I'll present in a sec. And if you know, and your book says it this way, side, side angle, you also use the law of sines. And this gets exciting. Yeah. These all use the law of sines. Okay? What's left to know about a triangle? What are the other pieces of information you could be given?
Oh.
If you have to be given three pieces to solve
Angle,
them.
angle, side, side, side.
Angle, 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 side, 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 and one other one.
Side, angle, side.
Side, angle, side. That covers it, actually. If you know side, angle, side, and this very specifically refers to knowing two sides and the angle in between them, or if you know side, 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 which refers to knowing these three sides, and I should be indicating that these sides aren't congruent, not that they are.
And then it is in the right triangle.
And you're not in the right triangle. Then you'll use what's called the law of cosines. So these are the cases. Okay? I left out angle, 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 because then you can figure out the proportions, but if I just give you three angles, you can't know what size the triangle is. It could be any size and have the same three angles. We'll discuss that a little bit later. So these are the 5 cases we're going to talk about. This one gets the most exciting. Part of that may wait till tomorrow. So you get the general idea. So throughout this week, I'm going to be throwing bits of information at you. Here's a side and 2 angles. I'm going to have to tell you where they are in the triangle, because you're going to have to know whether the angle is in between the 2 sides, whether I'm talking about 2 angles in a row and then a side, and then you're going to have to pick which rule to use. Okay? Today we're only going to do law of sines. Alright. Here's how the law of sines works. I thought about proving where this comes from, but that would probably take about 20 minutes or half an hour that we don't have. So, actually for this one, I don't need to write it for this one. It's law of cosines. I always mix the letters up. The law of sines is the sine of the angle of A in a ratio with the side A is equal to a proportion with the sine of the angle B to side B, which is opposite this angle, is equal in a proportion to the sine of the angle C opposite the side C. The sine of the angle of the littlest side opposite the littlest side's length. The sine of the angle opposite the medium side in a proportion with the medium side's length. Sine of the angle of the biggest side opposite the biggest side lengths. These proportions will all be true.
I feel like I've seen this before.
You may have.
I feel very unfriendly.
Alright, that's fair, Dean. This gets a little more clear with some examples. So let's say I tell you, redraw my triangle over here. But you guys saw this last year, right?
Yeah.
Okay. Alright, let's say I give you, here is angle A. This looks like it'll be B, this looks like it'll be C. Have I labeled my triangle correctly? All the right letters opposite all the right sides?
Yes.
Okay. Let's say I tell you that angle B is, now help me make sure these add up to 180, is 35 degrees. Okay? Angle A is...
Wait,
Yes?
I thought... Aren't the angles usually lowercase? Or is it the opposite?
No, this is what your book's doing. Remember Pythagorean theorem is always lowercase a squared
Yeah.
plus b squared equals c squared? Okay.